Hey, all you Shrek fans. Today we're going to talk about rational functions. You can see an example of a rational function down here, and it's already been factored for us so that this example goes a little easier and doesn't take up as much of your time. But let's talk about what a rational function is. What it is, a rational function is a function that results when we divide two polynomial functions. Okay, so if we were to multiply these two out, we would get two polynomials, right? And so our goal today is to look at what is the domain of these polynomial functions. So we're going to look at the domain, all right? So let's look at this and notice, okay, that when x equals 3 and when x equals -3, okay, then that's when the denominator equals 0, all right? And so we can't divide by 0, all right? So we can't divide by 0, so we have to exclude those from our domain. And so what I would say here is that our domain is -infinity to -3, -3 to 3, and 3 to infinity. So the only thing there, the only thing with rational functions is we cannot divide by 0. All right, so we cannot divide by 0. We'll say that here. So its domain is all real x values where the denominator, let's spell this correctly, denominator, there we go, denominator is not equal to 0 because we can't divide by 0. All right, so let's take a look at this function on Desmos, and we'll see how Desmos shows us the domain. All right, so here we see the graph, all right, and you guys should remember this from last year. But you can see here, so x is -3. I'm going to graph that here. X equals -3. All right, so remember, okay, this line here, x equals -3 is a vertical asymptote. Okay, so wherever we have vertical asymptotes, we have to exclude that from the domain. But if you remember, we have we have 3 parts here. But when we look at the graph, I see 1 and I see 2. Well, the other parts is this right here, x equals 3. So notice what happens when we go to x equals 3. Let's see if we can see it here as we go through. There it is, here it is, there, right there. Okay, so Desmos doesn't show it to you, but there is a hole in the graph, and you have to click on it to see it. All right, so there is actually a hole in the graph. All right, so x equals 3 is a hole in the graph. Okay, now why does that hole exist? Well, that hole exists because we have x minus 3 here and x minus 3 here. If we were to write another function and call it g of x and call it x plus 2 over x plus 3, well, those two graphs look very, very, very much the same. Okay, so the red graph and the purple graph here look the same. Okay, if we go to the purple graph, we are going to get a value at 3 right there. Okay, we get 0.833, but remember we saw a hole on the red graph. So actually the red graph and the purple graph are not the same. They're the same for every other point except for x equals 3. Okay, because we have this in the denominator here, you must exclude it. Okay? All right, so different functions, but the graphs look the same. All right, and so those are the things you need to look out for when we're finding the domain. So how about we correct that? There we go. Its domain is all real x values where the denominator is not equal to 0. So these are all the places where the denominator is not equal to 0. Even though we had to exclude this here, all right, which we could cross those out, but Technically, we cannot because it's in the original part. So that creates a hole at x equals 3. All right, guys, like I said, we're going to make this short, so hopefully that helps you finding the domains. Stay tuned for the remainder of this lesson as we talk about end behaviors of rational functions.